didn't work. So I think that I should probably skip half of my talk because most of the topics I wanted to talk about today have already come up in the previous presentations and probably much better than anything I can say about them. But so the idea of cross-cohort work approaches, I think from my perspective, there are two different approaches to cross-cohort work. And one has to do with data pooling, and the other one has to do with the integrative or the independent analysis of multiple studies. And in terms of data pooling, when we pool data, we could be doing what we call the aggregate data meta-analysis, like the typical type of meta-analysis that we do after, for example, a literature review, that type of thing, where we collect different published estimates, for example. Or the individual patient meta-analysis, and that is when we go back to the different studies, we get their data, and we pull all the data together in a big model, and somehow we account for the differences across the different studies. There's a third possibility that is a mix of aggregate and individual patient meta-analysis. And if you want to learn about that, I suggest you go to the papers by Julian Higgins, and he has quite a few papers developing that methodology. I believe that the individual patient meta-analysis is an approach that is very helpful when we have studies where we don't have many cases, for example, of a rare condition. Then you want to increase your power to detect an effect, and you pull all the data together as a way of improving that possibility of detecting an effect. And it's very useful, it's very common in randomized clinical trials, but it's technically quite challenging. And then we have the other approach, the integrative or independent data analysis, and it's more about along the lines of the coordinated analytical approach, and that is very similar to what we have seen in some of the presentations today. But the idea here is more about trying to identify patterns of results, of consistency of results, and try to evaluate whether the results are replicable across different studies or not. So there are, from my perspective, these two types of cross-cohort work have different aims. The data pooling and the integrative data analysis require different levels of data harmonization. And when we talk about harmonization, there are different ways of thinking of it. One could be the qualitative or the statistical harmonization. And in terms of the qualitative harmonization, is that where there's no statistical method involved. So it could be, if you're thinking of BMI, it would be saying, well, someone is overweight, normal weight, or underweight. So it's creating thresholds, but there's no method, statistical method behind that, the use of those cut points. And then we have the statistical harmonization, where we have to have some sort of statistical method applied to the data, so we somehow transform one variable into another variable. I don't think these are common practice in meta-analysis, and sometimes that's an aspect of the meta-analytic approach that I tend to question, is that unless we do some sort of harmonization, when we are meta-analyzing data, we may be meta-analyzing estimates that are not comparable. So we have to be careful when we are doing some sort. Even the standard meta-analysis that we tend to do after, for example, a review, sometimes we pull data that is dangerous to pull. And also in terms of the harmonization process, it could be prospective or retrospective. And Susan was talking about the prospective idea of standardization, where we are thinking we had to collect new data, or we had the intention of creating new data sets, but we can plan in advance of how to collect new data in such a way that it can be harmonized and it's consistent with the data we already have. And this is, for example, the approach used by SHARE. SHARE is the SHARE is the equivalent of ELSA. Do you know the English Longitudinal Study of Aging? This is the SHARE is an initiative where I think it's 13 European studies have collected data following ELSA and HRS, the Health and Retirement Study. So when they started the data collection, they said, we are going to collect data in such a way that is directly, or as directly as possibly comparable with ELSA and HRS. So that would be an example of prospective harmonization. And then we had the retrospective harmonization, that is what we are trying to deal with. Right? So we have the data, how we deal with that data once the data is already collected, and how we harmonize the data. So in terms of data pooling, I'm going to talk about some approaches using cognitive aging. That's my area of research, but I hope that the examples can be transferred into other research areas, and the ideas should be the same. So when we're thinking of pooling cognitive data, researchers so let's say, if you have a binary outcome, it should be easy to harmonize binary outcomes. You either have a condition or you don't. You are demented or you don't, or you are not. But if you have cognitive tests, then it's much harder. And there are many, many challenges that people have to face when they are trying to harmonize cognitive outcomes. Most of the times, we don't even have access to the answers to the individual questions asked in the cognitive tests. What we have is the sum score. So we don't really know how that sum score was created. And that is already a challenge. We have an example here that I included in the practical as a preview of what was going to come today. This is an example of the mini mental state examination. It's a test of global cognition. It's the most widely used test to evaluate cognitive function in older individuals. And we have the total score is 30. So when you go to, let's say your grandmother has a fall, and then you take her to hospital, this is the type of questionnaire that she will be asked. And the idea is that psychiatrists and nurses have cut points where, according to the result of the test, they can tell whether the person's cognitive function is okay or is not. So this is the type of test that they have. And as you can see, there are some questions that are very easy, like what is the year, the season, the date, or the month. Even if you ask me the date, I probably don't know the date, but this is the type of very simple questions. And then the questions change, and one of the questions, for example, is this one: is spell the word world backwards, or discount 7 from 100, and the questions have different difficulty. And when we want to do multi-study work, cross-cohort work, and we have to test people with a questionnaire like the MMSE, we have problems even with the translation of the questions. So if we are going to test individuals in different languages, the translation of the word world has to be such that the word in the other language has to have a similar level of difficulty as the word world in English. but we don't really know whether, most of the time we don't really know whether that is the case, because all we see when we are using cross-cohort data are the final scores. We cannot, theoretically, these things should have been tested before the data was translated, the questionnaire was translated. But this is the type of challenges that we face. So the difficulty of the items may change, may vary between the different countries. And there are variations even within a language. This is an example that I always cite. Within a language, there will be variations depending on geographical regions. For example, in the US, where they have this big influx of Latino migrants, and they want to test people in Spanish, they have serious issues because they say, okay, they are all Latinos, they all speak Spanish, but depending whether you come from Argentina, Uruguay, El Salvador, Guatemala, Mexico, each of those countries have their own version of some words. So when you choose the word that you're going to use, you have to be very sensitive to all these variations within a language. And those are all differences that are very often ignored when we are trying to do cross-cohort work. So there would be a level of harmonization that should involve item harmonization. And there's another level of harmonization that is more general, and this is where we usually work. We tend to ignore item level, and we go for the global measure. And in cognition, these are the three methods that people have used more often are the T-scores, C-scores, and the calculation of some sort of latent variable. And I'm going to discuss very briefly each of these methods. T-scores is probably what you have heard about. I mean, it's a natural, more intuitive approach. We standardize the scores. For example, we start with some sort of normalization of a score. For example, we say, well, we're relative to a distribution with a mean of 10, a standard deviation of 3, some sort of values there. Then we regress those T-scores on some variables that may affect the harmonization, like age, sex, and education, for example. We calculate the residuals as the difference between the actual score and the predicted, the scores predicted by the regression. And then we convert those residuals to T-scores. And the idea here is that those T-scores are interpreted as how an individual's score on each of the cognitive measures compared to the average score for individuals with certain characteristics. So that would be the easiest way. C-scores is some sort of refined version of the previous one, of T-scores. The idea here is that you are somehow aware of some differences in the subgroups in the population. So rather than standardizing in a general way, you standardize relative to a particular group. So for example, here we say, we standardize, we calculate C-scores as the raw score minus the mean score for a group of women who are aged 7 to 74 with 8 years of education. So that is my reference population. So I'm standardizing relative to these individuals, these women with a certain age group, within a certain age group and with a certain age. The problem is that C-scores and T-scores ignore differences between the measurement properties of the scales. It's like a big blanket. So you have some idea of differences between the groups and the individuals, but you don't really take into account whether there was any biases or skewed distribution. You just standardize relative to a group. And this is the approach that is technically the most challenging one, and it would be, you might have heard of this. This is the approach that's called that's known as IRT, item response theory, and it requires some specialized software. But the idea here is that we have the overall score, and that overall score is considered as counts, and those counts represent the correct number of items, the correct number of answers to the different items. So the idea is that the overall score is modeled as a binomial distribution with a certain probability, and this is the probability of answering each of the items correctly. And you can model that probability depending on certain covariates. You can also model the sigma, which is the standard distribution of this latent variable, and you can link that the log of the standard deviation also to some covariates. The idea here is that each of the so the overall sum is modeled as a binomial. I don't know. Do you remember the binomial distribution? You have to repeat, throw a coin 10 times, and you want to calculate the probability of having 4 faces. Right? That is the distribution, the binomial distribution. Here is the same. Each item has a certain probability of being correctly answered or not. Okay? And that is what you are modeling. And that probability depends on an item difficulty. And that is, you have to make, so you are interested in trying to understand whether that item difficulty is similar across the different studies. That's why I'm saying this is not easy. But I think it's possibly the best way of doing it. It has some problems. I don't know, again, going back to your A-level probability course. The binomial, one of the assumptions of the binomial is that all these different attempts, so every time you flip a coin, the different experiments are independent. So flipping the coin, the result of is an independent from one attempt to the second attempt, and so on. So that means that all those different attempts, when you have longitudinal data where the individuals are the same individuals repeating the same test over time, that assumption of independence is going to be violated.
But they can be serially correlated.
It can be serially correlated, but that's another level of complexity here.
So the assumption can be non-violated.
It can eventually be non-violated. Testing whether that is testing all this independence and factorial invariance and things like that, it's quite complex and requires specialized software, but whereas the T-scores and the C-scores, if you want, is something that can be done even in Excel. But this is possibly the most recommended approach. And if you wanted to learn more about this, I would suggest, for example, Ardo van der Hout at UCL in the Department of Statistics. He has published a lot on IRT. And Jean-Paul Fox in the Netherlands is someone also who's an expert in IRT, and they work on cognitive data. So I suggest you go to their papers. So if we want to say we have various studies, and we had to say, okay, which way do I go? Of these 3, T-scores and C-scores are really easy to do. the latent variable approach or the IRT model is more complex. What should I do? Well, T-scores are, as a method, is worse than C-scores. There's this assumption that the sample characteristics are identical across these different samples, and this is an assumption of T-scores that it's a bit too strong. So you may want to consider C-scores instead, because you standardize relative to a specific group. Within a study standardization, this T-scores is not desirable. It ignores difference in scale and sample distributions. And possibly the latent variable approach is the recommended method, but it's more complex. One of the handouts that we prepare for you is a paper on statistical methods for harmonization. That's it's a bit of a technical paper, but it's one where they've done exactly this, right? They said, okay, there's a review of methods used in standardization of cognitive variables, and they did a sensitivity analysis in the sense that, given the data, they applied various methods to the same data. So they could test what works and what doesn't work, and what's the best approach. This is a table that I borrowed from a technical report that's also prepared by the same group of people. It's Lauren Griffin and some colleagues working in Montreal, where they have discussed the assumptions and how the different methods can be applied. And again, this information should be in that paper, and I find it very useful and very helpful. It's the first time that I've seen a discussion of the different approaches with a discussion of the assumptions and what you can learn from one and from the other. I find this paper really interesting. I suggest you go for it. And that is in terms of the statistical methods using harmonization of cognitive outcomes, at least, with the aim of data pooling. If we take the other perspective, the integrative data analysis approach, we said that the integrative data analysis approach has to do with looking for consistency of associations, consistency of patterns, and trying to see whether the results replicate across different studies. There has been very interesting and relatively recent discussions about why most of the published research findings are false by Ioannidis, and quite high-profile journals publishing work and discussions about irreproducible research and why these things, why we are struggling to publish and to find results that are reproducible across samples. You can see this, right? Can you? Can you see this table? Sorry. Well, so I'm going back to an example that I am very keen on, and it's the effect of education on cognitive aging. And I'm using this example to illustrate some of the problems that we have in cross-cohort work. So there's this idea that so if you are more educated, when you become old, you lose your cognitive abilities at a slower rate than people with less education. So there was a very there was a review, I think in 2001, age is no kinder to the more educated or something like that. And then this is an update. It's a recent update of that review. In the original review and in this one, they of course, they went through papers, and the conclusion was almost what we would have expected without the review, is that the results are all over the place. And one of the reasons both authors cite are methodological differences. So, I don't, you can't see this, but for example, here, this study used logistic regression. This other one, ANOVA. I don't know, mixed models, growth curve modeling, linear mixed modeling. Actually, these last three are the same with a different name, but this also didn't, didn't seem to notice. Anyways, these are nonlinear latent process, latent growth curve modeling, linear mixed effect modeling, unconditional and conditional growth modeling. Each paper did what they thought was best. Obviously, the results are not going to be consistent. And that was something that I don't think they needed to do the review to find that. So, they said, well, their results are all over the place because each study fitted a different model. So we should not expect to have consistency. The idea that we had with Andrea Pichin and some other colleagues is, okay, let's try to do the same model across the different studies, and in that case, we will not be able to claim that we have differences in the methods. We are going to have a consistent, coordinated analytical approach across various studies. So that source of heterogeneity, of diverse results, is not going to be there anymore. So when we talk here about this coordinated analytical approach, we are thinking of the same model, in the sense like a latent growth model or a mixed effects model, random effects model, but where we center the covariates at exactly the same values, and we code everything the same across the different studies. So the interpretation of our output will be comparable. The centering of the covariates is particularly important in this case because the fixed effects of the model that we are fitting, of the random effects model we are fitting, are relative to where you center the covariates, are conditional on those covariates. So in this case, we use the mini-mental state examination, that test that I mentioned before, and we use data from 6 longitudinal studies of aging. We had the Canberra longitudinal study, where participants were tested in English. Then we have age 70, that is this is a cohort of individuals who were 70 years old in Sweden, but it's a single age cohort. Then we had HOPE, that's another study in the UK. OPTO is a study of twins that where participants were tested in Swedish. Then we have LASA, this is the longitudinal study of aging in Amsterdam, and another Swedish study, SATSA. Before going into the analysis, we try to understand the data, and I think that's a crucial step in data harmonization. It's almost impossible to do any data harmonization if you don't really understand your data, the different studies very well. So all sorts of descriptive statistics, and try to see what's the follow-up. So what we were trying to do was try to understand possible sources of differences across the studies before analyzing the data, which I think many times, so people like me with a statistical background, we like the data. We tend to go into the data. Right? But I think we need to take a step backwards and say, we really need to know what we are doing here. So the best way to do that is to sit down and tabulate data, do frequency analysis, all that type of descriptive that is before the data analysis. We had differences. For example, Canberra had 4 occasions that were about 3.5 years apart, Hope, that had 4 occasions, 4 years apart, Opto 5 occasions, about 2 years different follow-up. LASA had 5 occasions, and SATSA also had 5 occasions with 3 years apart. The other thing that came up here is that something that Jenny and I think that almost everyone who talked here before today mentioned that we had difficulties with the data, with accessing the data. We are part of a longitudinal of a network of longitudinal studies of aging, but we work with different groups. And for example, we had all the data except for 8. So, we had the physical data. The data was on our computers, on our servers, for all the studies except for SATSA and age 70. SATSA, the way that we work was we said we need these descriptives. We send them code. And then once we knew the data, we said, well, this is the model that we are going to go for. We prepared the scripts in various software packages because there were going to be different people involved in SATSA. They ran the analysis for us. In age 70, there was a postdoc who was helping us, and he was based in Sweden, and we had to go through a similar procedure. So it's not that we had all the data with us. So we fitted the same model. So it's a latent growth model, it's a random effects model for longitudinal data. We adjusted the intercept and the rate of change, so the level and the rate of change for the same variables, so it were age, sex, and education. And sex was coded as 0 for male and 1 for female in all the studies. And then we ran the analysis using 2 sets of covariates. One that was common across all the studies, where the covariates were centered at age 83 with 7 years of education, because we found that those 2 values were where the distributions overlapped the most. And then for each study, we said, well, we are going to take the median value of sex and education within each study, and we are going to fit a different model within each study. So we wanted to see how the common centering and the study-specific centering affected our results. We had a problem here, because in age 70, they were all of the same age. So this adjustment for age was not going to work, was not really necessary. And also we had an issue with the coding for education, because in this study, education was coded as less or more than 6 years. And in SATSA, they had 4 categories. It was like primary school, secondary school, university, and post-university. So we did this centering, and for these 2, we analyzed them independently. So we tried to harmonize wherever we could, and then try to do subgroup analysis in these other studies. I'm almost done. So 6 studies. What we found is that the results were quite consistent, except for, if you look at this here and this other one. This is the oldest study. So we would expect that these people are going to decline faster. Education was consistently associated with the level but not the rate of change. And when we try to figure out why is this one so different from the other ones, what we realize is this is the Opto study. It's a study in Sweden. And they made really big efforts to get absolutely everyone in the follow-up samples. And that means that absolutely everyone is including those who were becoming demented. So, whereas the other ones, in the other studies, once the people became demented, they were removed from the sample. So what we did is we ran the same analysis, using the information of the individuals up to the point of dementia diagnosis. And when we did that, this group became this other one, which is much more similar to the other ones that we have here. Right? So we've managed to identify and to explain why these inconsistent results were there. So the overall, so this is the message. The different centers of covariates influence the trajectory parameters, but not the association with the different covariates. So we found this consistency that we were after. As I mentioned, it was not always possible. But where it was, we got a really nice and interesting, what I think, it was an interesting result. And I'm not a big fan of meta-analysis because of what I said before. Right? People tend to pull things that are not comparable. But what we think is that even if your final aim is a meta-analysis, this coordinated approach is a way of generating input for that meta-analysis, an input that is comparable in that final meta-analysis. Because now the results that you have in the coordinated approach are estimates that represent the same quantity across the different studies. So we find that this is a promising approach. Here's a list of references that you can request my presentation if you want the list of references. Isabelle Fortier in Canada, she's developing really nice work with the Maelstrom. There's a catalog for looking for data. And then this is a paper that I was mentioning about the methodological approaches that I strongly suggest you read. And one more comment is that with this group of people that I work with, we have moved from that idea of requesting data to different people. And so we have come up, for example, the last workshop that we have run, we invite individuals from the different cohorts that we have previously identified as studies that have the data that we would like to analyze. And we work together over a couple of days. So we don't touch each other's data, if you want. Right? It's a really interesting way of working. And it involves quite a bit of work beforehand preparing the data. So we have to think and suggest how they need to, what data format they need, what variables, and all the tabulations and the script. It has to be done beforehand. But it's another model for multiple study work that seems to be promising. And everyone gets papers. That's always important. And you don't have to go through that issue of sensitivity of sharing the data and depositing copies of your data in another institution. So that's it.